Excellent guys, so let's now apply this to a worked example and put it into practice when factorizing polynomials, but instead of using long division, we're now going to use synthetic division. So let's check it out.
Alright, so in this worked example, the question says factorize the following as fully as possible. That is for part A, x cubed minus 2x squared minus x plus 2, and for part B, x to the power of 4 plus x cubed minus 13x squared minus 25x minus 12. Alright, so for part A, let's go through and actually define the polynomial first of all. So we're going to call this p of x is equal to x cubed minus 2x squared minus x plus 2. Now in step 1 it says look for factors of the polynomial by applying the remainder slash factor theorems. Alright, so what we need to do is just see which one's a factor by trial and error. So what I'm going to tell you to do is look at the last one here, because that's going to give us a hint at what to actually use to factorize it. So it says 2, so I'm looking for factors of 2. Now I know that 1 and 2 are factors of 2, so let's just see if x plus 1 is a factor. Right, so because I'm looking to see if x plus 1 is a factor, what I'm going to do is substitute in p of negative 1. And that's going to get me negative 1 cubed minus 2 times negative 1 squared minus negative 1 plus 2. Alright, going through and simplifying that now, negative 1 cubed is negative 1, negative 1 squared is positive 1 times negative 2 is negative 2, negative 1 becomes a positive 1, and positive 2 at the end. So that ends up getting us with the negative 1 and the positive 1 cancelling out, and the negative 2 and the positive 2 cancelling out gets us 0. Therefore, because p of negative 1 is equal to 0, x plus 1 is a factor. And I love it when it comes up straight away and we don't have to go looking for other ones. Right, because I know it's a factor then, what I can do is use a new method that I'm going to show you now, which is called the synthetic method. Now, the synthetic method for dividing is actually a whole lot faster than using the long division method that we've done before. To do that, what you need to do is you've got to go through and draw out a box like so. Alright, then what you're going to do is you're going to draw a little plus sign in here, and you're going to write a little times sign outside. Now the next thing that needs to happen is this plus 1, well because it says plus 1 you're going to write a minus 1 here, and then you're going to go through and write out all the coefficients of p of x. So if you have a look here, the coefficients of p of x up here is 1's out the front of x cubed, negative 2's out the front of the x squared, negative 1's out the front of the x, and positive 2 at the end. Then what I go through and do is I write a little 0 here, and it's always going to be 0 underneath the first one. And what you go through and do now is you go 1 plus 0 is 1. You then do the times, so anything you do outside this area is a multiply, so you go negative 1 times 1 is negative 1. Now we're back inside the box again, so you go negative 2 plus negative 1 is negative 3. We're outside again, so it's multiply, so negative 1 times negative 3 is positive 3. We're back inside again, so we add, so negative 1 plus 3 is 2. Negative 1 times 2 is negative 2, and 2 plus negative 2 is 0. Now this is good because you always want to get a 0 at the end, because what that is it's our remainder. And what the rest of it is, well, that's our constant here. This here is our x, and this is our x squared. So it always just increases by a power of 1 for the x as you go along. So what I can now write out is p of x was originally equal to x to the power of 3 minus 2x squared minus x plus 2. But what I now know is that when I went through and divided this, that is p of x, by x plus 1, I ended up getting p of x is equal to x plus 1, because I know that was a factor, multiplied by x squared, because that comes from here, negative 3x, because that comes from here, plus 2, because that also comes from here. Now all I need to do is go through and look to factorize the last bracket. So the factors of 2 that add to negative 3, well the factors of 2 are 1 and 2, and negative 1 and negative 2, and which ones add to negative 3? Well, it's negative 1 and negative 2. So you get p of x is equal to x plus 1, x minus 1, and x minus 2. So in its fully factorized form, you get p of x is equal to x plus 1, x minus 1, x minus 2. That is, this one here, fully factorized, is this here. Alright, so coming over now and factorizing part B, that is x to the power of 4 plus x cubed minus 13x squared minus 25x minus 12. What I once again need to do is go through and define the polynomial. So we'll call this one f of x. Now it doesn't matter really what we call it, but that's why I like to change it up a little bit. So you've got f of x is equal to x to the power of 4 plus x cubed minus 13x squared minus 25x minus 12. Alright, so f of x is equal to that. And then what I need to do is go through and look for factors of negative 12 so that I can use those in order to be able to factorize it. So the factors are negative 12. Let's just say x plus 1, for example. Let's see if that's a factor. So right, is x plus 1 a factor? Alright, to do that now, I go through and I write f of negative 1 is equal to negative 1 to the power of 4 plus negative 1 to the power of 3 minus 13 times negative 1 squared minus 25 times negative 1 minus 12. Alright, go through and simplify that now. Negative 1 to the power of 4 is going to be 1 plus negative 1 to the power of 3, well that's going to be negative 1. Negative 1 squared, well that's 1 times negative 13 is negative 13. Negative 25 times negative 1 is equal to positive 25 and minus 12. Alright, let's see if that adds up to 0. So we got 1 minus 1 is 0, minus 13 is negative 13, minus 12 is negative 25, plus 25 is 0. So you end up getting f of negative 1 is equal to 0. That's good news, so therefore x plus 1 is a factor. Now because I know that, what I can go through and do is start to factorize. So to do that I need to use synthetic division. So I'm going to come down here like this, draw out my little box, and I'm going to write negative 1 here because it's the opposite of what you see here. You're going to write your plus here, you're going to write a times outside the box, and then you're going to go through and write out all the coefficients of your f of x. So the coefficient of the x to the power of 4 is 1, that you can see here. The coefficient of the x cubed is also 1. The coefficient of the x squared is negative 13. The coefficient of the x is negative 25. And the last one, the constant, is negative 12. Alright, and of course the last step that you need to do is always write the little 0 down here. Now whenever we do inside the box, you go 1 plus 0 is 1. Negative 1 times 1 is negative 1. 1 plus negative 1 is 0. Negative 1 times 0 is 0. Negative 13 plus 0 is negative 13. Negative 1 times negative 13 is 13. Negative 25 plus 13 is negative 12. Negative 1 times negative 12 is 12. And negative 12 plus 12 is 0. Which is great once again because you want your remainder to be 0 at the end. Therefore, what I do is I go through and I write out my x's, etc. So I go, that's there as my constant. I have my x here, my x squared here, and my x to the power of 3 here. So f of x was equal to x to the power of 4 plus x cubed minus 13x squared minus 25x minus 12. We also know though, when I partially factorize it, I get f of x being equal to x plus 1 because that was the factor, and then I need to multiply that by x cubed because it comes from here, the x cubed, plus 0x squared, so I don't need to write that in, minus 13x minus 12. Alright, but I could still possibly take this a little bit further and factorize again. I've got x to the power of 3 as a factor there. So to do that, what I go through and do is I look for factors of negative 12. Now, let's just try out another number. For example, let's see if x plus 3 is a factor. So I'm going to write x plus 3 a factor. Alright, now to find out that, what we need to do is we're going to call this g of x, so it's just something slightly different, because if it was f of x we'd have to write all of that. We've already defined it as f of x. So we'll call this g of x is equal to x cubed minus 13x minus 12. And we want to see if x plus 3 is a factor, so we go g of negative 3 is equal to negative 3 cubed minus 13 times negative 3 minus 12. That's equal to negative 27. Negative 13 times negative 3 is positive 39 minus 12. And negative 27 plus 39 minus 12 is actually equal to 0. Therefore, x plus 3 is a factor. Alright, I'm going to come up here now and we're going to continue on with the rest of it. So I know that x plus 3 is a factor, so once again I'm going to come through and I'm going to draw out my box, and if I know x plus 3 is a factor, so I'm going to write negative 3, and I'm going to write my plus here, my multiplication sign outside the box like so, and then I'm going to go through and write out all the coefficients. Now the coefficients I get from my g of x. So my coefficient of my x cubed is 1, my coefficient from my x squared, well there's none there so it's actually going to be 0, my coefficient from my x is negative 13, my coefficient from my constant, or sorry, just my constant is equal to negative 12, and of course I write my 0 here. Now 1 plus 0 is 1, negative 3 times 1 is negative 3, 0 plus negative 3, well that's going to be equal to negative 3, negative 3 times negative 3 is positive 9, negative 13 plus 9 is equal to negative 4, negative 3 times negative 4 is 12, and negative 12 plus 12 is 0. Once again, that's what we want at the end there. So I can now go through and write out my x's here. So I've got my constant here, my x, and my x squared. So I know that f of x will be equal to x plus 1, x cubed, minus 13x minus 12. But what I can do is I've factorized this a little bit more. So I know that f of x is equal to x plus 1, still at the front. Then I know that x plus 3 went in there, because x plus 3 was a factor, and I was left with x squared minus 3x minus 4. And the last thing I need to do is go through and find out the factors of negative 4 that add to negative 3. What to do, that's going to be negative 4 plus 1 will get me negative 3. So you're going to get f of x is equal to x plus 1, x plus 3, and once again, negative 4 plus 1 will get us 3, so it's x minus 4, x plus 1. Now that is almost fully factorized, but what you can see here is I've got x plus 1 repeated, so I've actually got to write it as f of x is equal to x plus 1 squared, x plus 3, x minus 4. And now f of x has been fully factorized.
Alright guys, thank you very much for tuning into today's lesson, which was all about how to factorize polynomials. That is, cubic and quartic expressions. Now, like always, make sure you stay tuned for the very next lesson, because we're actually going to look at how to factorize polynomials once again, but using the sum and difference of two cubes. So of course, say hi to your maths teacher for me. Mawsy out.